Hello students and welcome to Crop Science 6049. Today we are going to look at soil composition and its characteristics, and we are going to focus mainly on the main soil constituents. By the end of this lesson, you must be able to describe the four components of soil and also to identify the soil minerals. Discuss the significance of soil water and explain the role of soil air in plant growth and microbial activity. So let's take a look at the main soil constituents. As a whole, soil is made up of four constituents, which include the mineral matter, organic matter, soil air, and soil water. This is the diagram that is representing the different soil constituencies. In an ideal soil, we have 25% air, 25% water, 5% organic matter, and 45% mineral matter. However, these can fluctuate depending on where the soil is located. A soil may have more than 25% air or more than 25% water. And a soil may even lack organic matter. For example, if a soil is found in the desert, it may have an insignificant amount of organic matter. So this diagram is simply representing an ideal soil, but the constituents, they differ depending on where the soil is found. So let's take a look at the different soil minerals. Soil minerals are natural inorganic compounds composed of elements arranged in a crystalline pattern with a defined composition. Soil minerals are inorganic, which means they don't contain any remains or anything that has to do with plants and animals. It is the largest component of soil by volume, making up about 45 to 49% of the soil by volume. Soil minerals are divided into two. We have primary minerals and secondary minerals. So let's take a look at primary soil minerals. The primary soil minerals are those minerals that are formed owing to crystallization of the molten magma. So these soil minerals are formed when magma solidifies. They are broken down remains of massive rocks which remain unaltered chemically since deposition and crystallization from molten lava and retain much of the composition of the parent rocks from which they originated. So, when the rocks are formed as magma or lava solidify, these minerals are then formed. And when these rocks are then weathered, that is when these minerals are then added to the soil. Primary minerals are products of accelerated physical weathering, and they are often bigger and of a coarser texture and make up gravel, sand, and some silt. Let's take a look at these examples of primary soil minerals. We have the feldspars, and the feldspar, they are aluminosilicates containing various amounts of sodium and potassium. And common feldspar, they include orthoclase, albite, anorthite, and microline. The second type of a primary mineral is the mica or the micas, and these, they include iron and aluminum silicates. The two most important types are muscovite, which is a white mica, and potassium aluminum silicate, and biotite, which is a black mica, a potassium, aluminum, magnesium, and iron silicate. The third one is quartz. The fourth one is amphiboles. And common amphiboles include hornblende, tremolite, and actinolite. We also have pyroxenes, and common pyroxenes include rhodonite and enstatite. We also have olivine, epidote, tourmaline, zircon, and rutile as other examples of primary minerals. Now let's take a look at secondary minerals. Secondary minerals are formed at the Earth's surface by the weathering of the pre-existing primary minerals under variable conditions of temperature and pressure. So secondary minerals, they are formed after the weathering of existing primary minerals, and the weathering that usually occurs is chemical weathering. Secondary minerals include kaolinite, montmorillonite, chlorite. Kaolinite, montmorillonite, and chlorite, we are going to look at them later on in the syllabus. They also include allophane, immogolite, goethite, hematite, and many others. Let's take a look at the next soil component, or the next soil constituent, which is soil organic matter. Soil organic matter is the fraction of the soil that consists of plant or animal tissue in various stages of decomposition. So organic matter, it includes anything that comes from plants and animals that is in the soil, whether living or non-living, and at different stages of decomposition. Most productive agricultural soils have between 3 to 6% organic matter. However, the quantity of organic matter in the soil varies depending on where the soil is located. A soil that is found in a desert will have very little organic matter, whilst a soil that is found in tropical rainforests or in areas where there is a lot of rainfall will have more organic matter, probably even 10% or maybe 15%. Organic matter is made up of different components that can be grouped into 4 major types: living organisms, fresh residues, decomposing organic matter, and stable organic matter, often referred to as humus. So let's take a look at all these different types of organic matter in the soil. First of all, I want to look at living organisms. It is made up of bacteria, fungi, nematodes, protozoa, arthropods, and many other living organisms in the soil. We also have fresh residues. It refers to plant residues, animal or other organic substances that have been recently added to the soil and have only begun to show signs of decay. It does not include surface residue cover. So if a farmer adds green manure or plows under weeds into the soil, those weeds or green manure that have been added to the soil will then constitute fresh residues. They don't constitute fresh residues if they are on top of the soil. They have to be added to the soil. Next, we have decomposing organic matter. And this is the portion that soil microorganisms decompose because it is used as food by the organisms. Active soil organic matter decomposes faster than other components of the soil organic matter in response to management changes. The next one is stable organic matter. Stable organic matter include complex organic compounds that remain after many organisms have used and transformed original organic material. Humus is not readily decomposed because it is either physically protected inside the soil aggregates or chemically too complex to be used by most organisms. So stable organic matter, it constitutes humus. Next, let's take a look at the significance of soil organic matter, or the importance of soil organic matter. Soil organic matter provides food for different soil organisms. For example, earthworms, termites, and other organisms that use the soil as shelter. It is also a source of plant nutrients. As organic matter decomposes, it releases nutrients into the soil that can be absorbed by plant roots and benefit the plants. It also increases the cation exchange capacity of the soil. Right now, we are not worried about what cation exchange capacity is. We are going to look at it later in the syllabus. It also improves water and nutrient holding capacity. And how does it do that? It does that by improving the soil structure and transforming the soil structure into a cramped structure that is able to hold more water and nutrients. It also improves water infiltration in the soil. It promotes soil aggregation, improving soil structure. It buffers against fluctuations in soil pH. So organic matter acts as a buffer that resists change in soil pH. It also moderates soil temperature through its effect on soil color. So if organic matter is added to the soil, it darkens the soil. And a dark soil is able to absorb heat from the sun, which will change the soil temperature. Organic matter reduces the chance of soil erosion by binding soil particles together. Let's take a look at soil water. Soil water is water that is found naturally in the soil. There are three types of soil water. First of all, there is gravitational water. Gravitational water is water that is free in the soil and that moves in the soil under the force of gravity. We also have capillary water, water that is able to move from wet soil to dry soil using the capillary action. And lastly, we have hygroscopic moisture. And this is moisture that is held tightly to soil particles, and it is only found in dry soils. Gravitational water cannot be used by plants. Capillary water is the water that can be used by plants and be absorbed by plant roots. Hygroscopic moisture cannot be used by plants because it is tightly held by soil particles and is only found in dry soils. Let's take a look at the significance or the importance of soil water. Water serves as the solvent and carrier of nutrients for growth of plants. The process of weathering and soil formation depends on water. For example, chemical weathering cannot occur in the absence of water. It can only occur in the presence of water. The soil water regulates physical, chemical, and biological activities in the soil. For example, for many soil organisms, they only thrive in the presence of soil moisture. If the soil becomes dry, many soil organisms, they die. And also many chemical activities, they occur in the presence of water in the soil. It also helps soil microorganisms to undertake their metabolic activities. Water is also essential for the process of photosynthesis. Water also maintains the turgidity of the plant. It is also required for seed germination. Water protects plants from adverse conditions like drought and frost. Now let's take a look at soil air. Soil air is the gaseous phase of the soil. The main constituents of soil air are nitrogen, oxygen, and carbon dioxide. So what are the significance of soil air? Soil air supplies oxygen that is required for seed germination. It also supplies nitrogen that is needed for biological nitrogen fixation. It is a source of carbon dioxide that reacts with water to form carbonic acid that reacts with rocks, resulting in weathering. It also promotes decomposition of organic matter. So without soil air, decomposition of organic matter may not take place because organisms in the soil, they need oxygen in the air for them to respire in order to decompose organic matter. It also supplies oxygen needed for root and soil organism respiration. Thank you for watching. Don't forget to subscribe to this channel. If you have any questions, additions and subtractions, please write them in the comment section. If this lesson has benefited you, click the like button.